pig's on there. No. Sorry. What did you say?
There's the stand one. I missed that.
Oh, it's secant squared. It's secant squared. Dang it.
Actually,
Okay. All right, guys. So your test part 1 is in the grade book. Test 2 will go in very shortly. Test 1 was the multiple choice part where you're just picking answers. Test 2 is the part where you're actually like writing stuff out. That's taking a little bit longer to grade since my classes doubled last week. And I have a little baby at home. So sorry that I'm a slow grader. But you'll have the chance to do corrections next week. If you haven't really kept up with the school calendar, do you know what Tuesday is? It's meet the teacher night. So I'm not staying after Tuesday or Wednesday at all, but I'm staying after Monday and Thursday. So if you want to do test corrections and you need to come after school, those are going to be your days. If you have a 7th or an 8th off, I also have those off, but you would need to come Monday or Thursday. One of them's Monday's 7th, and then Thursday would be 8th. Okay. And if you have a class and you think your teacher would let you come, I'm fine with that. Okay. Good. All right. So last time you learned how to take a derivative. Remember that derivatives give you the slope of the equation or the graph at that spot. So let's take a look at number 1. Okay, you actually have seen tangent lines before when you were in geometry. Draw me a little circle, okay, in this top corner. And when you were in geometry, you talked about 2 different kinds of lines. You talked about tangent lines and secant lines. Okay, a secant line is going to cross your circle in 2 spots. So for example, here, that would be a secant line. Okay, because it's going to intersect your circle in 2 different spots versus a tangent line is only going to touch the circle at exactly 1 spot. And so what that means is it can't pass through the circle or it's going to hit it again. So your tangent line would have to look more like this. Okay, where it's just barely going to touch the circle. Okay, it's going to like tap the circle at just 1 spot and then keep going straight past it. Okay, so a tangent slope is how we are going to measure the slope of the curve. So for example, on number 1, it says draw a tangent line to the curve at -2. So -2 would be here. It would be right kind of down here on the graph. And then what I want you to do is draw a line that's sort of laid right up next to your curve, just like it was on the circle. So I'll do this one, then you do it on your paper. Okay, you want it to match how steep the graph is, and it's just going to kind of like kiss the equation and then keep going straight past it. Okay, just like that. Then it says, is f prime, that's the slope of the line that you just drew, positive, negative, or 0? So given that my line looks like this, is that a positive, a negative, or a 0 slope? Okay, positive. Then it says, how do you know? I'm going to put f is increasing. Okay, and you should already know that word from pre-cal. Increasing basically just means like it's uphill. Okay, second one. I want to draw a tangent to the curve at 1. So go to 1. That would be right here. And then I want to draw my line so that it just taps that 1 point and then keeps going straight. So you don't want it to cut through. You want it to just touch the end of it and then keep going straight. Okay, once you have drawn that line segment, I want you to estimate its slope. Is it positive, negative, or 0? 0 is correct. And then I'm going to put because f is horizontal. Okay, and remember that horizontal means that it's like a flat slope or a 0 slope. Okay, one more like that. Draw a tangent line to the curve at x equals, let's change this to a +2, otherwise it's the exact same thing. Okay, so we'll make that a +2. And then 2 would be right here. And then remember, I'm trying to draw that line so that it lays right up next to the graph. It's just gonna kiss it at that one dot and then keep going straight. So I want it to look kind of like that. Now, would that be positive, negative, or zero, what you just drew? Positive, which means that F is doing what? Increasing, very good. Okay, now, before we go on, I want to correct one little thing. Okay, remember that for circles, we said that your tangent line is only touches at one spot, right? Okay, this red tangent line, eventually, as I extend it out, is it gonna cross the graph again? Okay, yes, that's fine. Okay, it's just in that little area, it should only touch it once. But eventually, if I extend this guy out, okay, then it's gonna hit again. We don't care about that. We're just looking at in that little area, okay? All right, so let's get into what we're doing today is we're gonna write the equation for the little tangent lines that you just drew. There are two forms for the equation of a line. The first one is y equals mx plus b. Okay, this is the one people usually remember a little bit easier. What does the m stand for in y equals mx plus b? Starts with an s. Slope. Okay, remember that slope is going to come from the derivative now. So instead of you in algebra 1 counting the rise over run between two pretty points, blah, blah, blah. Okay, now for slope, we're going to use the derivative. Okay, then your b, we remember what that is? Okay, that's the y-intercept. Okay, however, since you won't be really graphing these much, you should know what that is, but this is the main one you need to be able to find. Okay, now, the second form for the equation of a line is point slope, y minus y1, mx minus x1. M is still your slope. And remember that to find the slope, we're going to use the derivative. Okay, because we learned how to find the derivative last class. And we know that the whole point of finding the derivative is to get to the slope. Okay, then the x1 and the y1 are going to be a point that that line has to pass through. Now, I want to point out to you that both of these involve a point. X1, Y1 is my point here, but my point on this one is the y-intercept. Remember, this is also a point. It's just a very specific point, okay? But 99% of the time, you're going to start with this guy right here. So take a look at example number 1. Let me show you what I mean. Okay, it says, given that f of 10 is -3 and f prime of 10 is a half, write the equation of the line tangent to the graph of f at x equals 2. Now, we don't have a picture, okay, but they told us some stuff about it. To write any equation of a line, we need two ingredients. We need a point and we need a slope. So write down point and slope. The point is always going to come from the original function f. They told me that f of 10 is -3. That means that 10 gives me a -3 y value. That's what that means. The parentheses number is the x, the answer is the y. Now, for my slope, they're telling me f prime of 10 is a half. That means my slope is a half. And remember, what do we use for the slope? We use the derivative. Okay? Then from there, you're going to write the equation of the line. The way that I write it is I'm going to do y blank equals blank x blank. And then we're going to go to each of those spots and fill in the numbers from our two ingredients. Now, m is the middle blank. What was my slope? Half needs to go here. I'm going to do 1/2 here. Okay. Then my x is a minus x1. What that means is that you're going to switch the sign. So if my actual x is a 10, I'm going to fill in a -10 to this parentheses. Okay, because the minus is built in, it's part of the formula. Okay, then for my y, I want to put minus y1, but my y is already negative. what am I gonna get if I minus negative plus 3? So what I like to think about is that the x and the y, you're just gonna put the opposite. If your actual y is a -3, put a +3 into your equation. Okay, from there, if you're just told to write the equation, this is done. Okay, so I'm gonna rewrite it over here. Y plus 3, 1/2 x minus 10. Okay, however, a lot of times, if it's a multiple choice question, like say we're talking about the AP test, okay, they'll give you answer choices that are in y equals mx plus b form. So you just have to know how to convert it, but it's very easy. Okay, you're gonna distribute the 1/2. What is 1/2 times x? 1/2 x. What is 1/2 on -10? -5. And then for me to get y by itself, I need to get rid of this +3, so I'm just gonna minus it across. -5 minus 3 more gives me what? -8, very good. Okay, so if it's a free response question, I would not waste any time trying to turn it from this to that. For free response, that's perfectly fine. But if you're trying to match an answer choice, you should be able to go from one to the other. Okay? All right, go ahead and turn the page. Okay, take a look at 2. Okay, this time they're not giving us the point and giving us the slope. We're gonna have to find it ourselves. So it says, write the equation of the line, tangent to the graph of f, for the function 3x squared plus 5 at x equals 1. You always need the same 2 ingredients. What do I need for the equation of a line? I need a point and a slope. Very good. So I'm going to do the point first. Then I'm going to come back and do the slope second. Anytime it says equation of a line, those are your 2 pieces. Okay, for the point, all that they gave me is that my x is a 1. So I know that it's 1 comma something. If I want to know the y value that comes with that, I'm just going to plug it in. So if my equation is 3x squared plus 5, I'm going to do 3(1) squared plus 5. 3 times 1 squared would be 3, and then add 5, 8. So my point is 1 comma 8. Now I want you to make a little note here that when you are completing the point, you're using f of x to plug into. Okay, regular f is going to give you your y value. Okay, but now that I want my slope, that's my second ingredient, I'm going to have to take the derivative. So we learned how to do this last class. Okay, but for slope, I'm going to need to use f prime of x. Okay, so let's review how to do that. To take a derivative, you're going to times the exponent down to the front, then you're going to take away 1 from the power. So I'm going to write f prime equals, it was originally a 3x squared, so I'm going to do 2 times 3 is, and then I'm going to take away 1 from the power, so instead of x squared, now it's just x. Then what's the derivative of 5, which is by itself? 0, very good. So this formula will tell me the slope at any x that I want what x? 1. Then I'm just going to plug in 1. So I'm going to do f prime of 1 equals 6 times 1, which is 6. And now I have my 2 ingredients. I have a point, I have a slope. That's enough information for me to write the equation of the line. So put y blank equals blank x blank. Remember that the slope goes in the middle. What was my slope value? 6. And then my x and my y, remember I plug in the opposites of those into the equation. So if my real x was a 1, I'm going to put a -1 in the equation. If my real y was an 8, I'm going to put a -8 into the equation. Now our goal is going to be to graph this and make sure that it's really tangent, but I can't graph it in this format. I'm going to turn it into a y equals mx plus b. So it's just 2 steps to do that. Times the 6 in. What is 6 multiplied by x minus 1? Very good. So I have y minus 8 equals 6x minus 6. And then I need to get rid of that minus 8, so I'm just gonna add that to both sides. So plus 8, which gives me what? 6x plus 2, very good. Now, let's graph that on our picture and make sure that it comes out tangent. Remember, this is y equals, I don't want to write on that question, but I guess I have to. Mx plus b. So I want you on your graph, go to 2. Okay, that's your y-intercept. So that would be right here. And then 6 is your slope. That's a rise over run. Now, if 6 is a whole number, what can I put it over? 1. So I'm going to rise 6 and then run 1. Rise 6, run 1. So here we go. 1, 2, 3, 4, 5, 6, run 1. One more time. 1, 2, 3, 4, 5, 6, run 1. And then if you draw in that graph, it should perfectly touch your equation. Okay, which you can see that mine does. Okay, and where is it tangent at? It's tangent at 1. That's your point that you found, 1, 8. Okay, does that kind of make sense? So rather than us just kind of drawing it and eyeballing it, we can actually find that equation. Okay, we're gonna skip the next one and turn to the next page, please. Okay, let's do number 4. So I have 1/8 x squared, and I want to write the equation of the tangent line at x equals -4. What are my 2 ingredients for an equation of a line? Okay, slope and point. Very good. So point and slope. Okay, for my point, I know my x is a -4. In order for me to find the y value that goes with that, where do I plug in? The original or the derivative? Okay, for the original, very good. So I'm gonna put here, use original. Versus when I come to the slope side, I'm gonna use the derivative. Okay? So I have a 1/8 x squared. My x is now a -4. What is -4 squared? -4 times 4 is 16. And then if I want an 1/8 of that, I'm just going to divide it by 8. What is 16 divided by 8? 2. Very good. We have our point. Next thing we need is our slope. And to find a slope, we're going to need to take the derivative. So my equation is 1/8 x squared, and I want f prime. I'm going to times the 2 onto the 1/8. What is 2 times 1/8? 1/4 is correct. Let's see how we got that. 2 times 1 on top is 2. And then I would keep it divided by 8. But 2/8 can reduce. I can divide them both by 2. So that gives me the 1/4. Okay. Then I need to power my x down. It was an x squared. So now it's an x what? Regular x. Good. Okay, then I'm going to plug in my x value. Remember, this is the slope at whatever x I want. I want the slope at -4. So I'm going to plug in a -4 to that. What is 1/4 of -4? What number would that be? -1. Very good. Remember, 1/4 just means divide by 4. So if I do a -4 divided by 4, that gives me -1. Let's write our equation of our line. Y blank equals blank x blank. Slope goes into the middle. What was my value for slope? -1, thank you. And then remember the x and the y's go in as opposites. So my original x was a -4. I'm going to put in a +4. My original y was a 2. I'm going to put in a -2. And then because in the notes, we're gonna graph it to make sure it's tangent, we're gonna turn it into a y equals mx plus b. What is -1 times x? -1x, thank you. What about -1 times 4? -4, and then I'm gonna add my 2 across. So that I have y equals -1x, -4 plus 2 is -2, very good. Okay, this is your m, this is your b. So now we're gonna graph that and make sure that my graph really looks tangent to the 1/8 x squared that's already graphed for you. So start at -2, that would be right here. And then if your slope is -1, I'm gonna put that over 1 so that I can do down 1, run 1, rise 1, run 1, but you're going down 1 over, down 1 over. So it'll look like this. But if I'm trying to if I'm trying to kiss the U, right, then I actually need to go the other way. So I'm gonna go up and back, up and back, up and back, up and back. Okay, and then once you hit that spot, you can just kind of use your calculator to draw your line. And you can see that right here at -4, that's where I touch my quadratic and then keep going. Okay, and not only are you just touching the quadratic, but you're perfectly matching its slope of -1 at that point. We kind of get the idea? A little bit? Okay. Most of your homework, you're writing equations. So I'm going to stop doing this part just because it makes it take longer, and we're going to do just a few more examples. So if you look at number 5, okay, we're going to stop graphing and just write the equations because that's the majority of what you have to be able to do. So here's my equation. 2x plus 5 cosine x. I want to write the equation of the tangent line at pi halves. So my point is here. My slope is here. Those are the 2 ingredients for a tangent line. And I know that for my point, my x needs to be pi halves. So it'll be pi halves, comma, something. Okay, I want to take that x, I want to plug it in. Remember, for the point, you're using the original. For the slope, you're going to use the derivative. So I want 2 times pi halves plus 5 cosine pi halves. And I'm literally just taking that x and I'm just plugging it into the equation. Okay, let's do this part first. What is pi if you divide it by 2 and then you times it by 2? Just pi, because the 2's are going to cross out. So this is really just pi plus 5, and now we need to know what the cosine of pi halves is. Okay, so if you're doing hand trick, pi halves is your thumb, right? Because it's 0, pi 6, pi 4ths, pi 3rds, pi halves. How many fingers for cosine are above your thumb? 0, so it's going to be 0. Now, if you haven't learned hand trick, that's fine. Let's think about the unit circle. And I know you wish you never had to look at it again, but there it is. Okay, do we remember where pi halves was on the circle? It is the top, very good. Pi halves is right here. And the ordered pair for that is 0, 1. Because remember, for the unit circle, it's always 1 away from the center. And then for cosine, do you remember if you pick the x or the y? Cosine was always the x value, which is what number? Still 0. So whether you're doing unit circle or hand trick, it doesn't matter. You're still going to get that this comes out to 0. And then from there, what's 5 times 0? Add it to pi. Pi is your y value. Okay, next we want our slope. For slope, we need a derivative. So I'm going to do f prime equals, what is the derivative of 2x? I'm going to write a little 1 there so I have a power. 1 times 2 is 2, and then my x drops to the 0 power, which means we're not going to put it, so it's just a 2. Okay, then for my cosine x, snow cone, bottom 2 are negative. And remember, for derivatives, you just go down the list. So if I'm at cosine and I go down one for the derivative, what am I at? Negative sign, and you'll just keep the 5 there. So. But remember, f prime is the slope at any x that I want. I want to use my x. So I'm going to plug in 5 halves. So I'm going to have 2 minus 5 sine 5 halves. Okay, if you do hand trig, you're still on your thumb. That's pi halves. I have 4 fingers on bottom. That means it's root 4 over 2, which is 2 over 2, which goes to 1. Okay, but if you look at the unit circle, you're still going to get 1 because you're going to find pi halves, which is the top of the circle. And remember, sine is the y value, which we already wrote as a 1. What is this going to come out to be? What number? -3 is correct. Okay, from there, you can write the equation of the tangent line. It's gonna be y blank equals blank x blank. Then you're going to plug in your slope to the middle, which is a -3. My x was a pi half, so I'll use a minus pi halves. And then my y was a pi, so I'll use a minus. Okay. And for the homework, okay, you would leave it, you'd type it in just like this. You wouldn't solve it out for y like we did on those first couple examples. Questions on that? Okay, turn the page, please, and we're gonna do number 8 next. Number 8 says, write the equation of the line. As soon as I read equation of a line, I know my ingredients. I'm going to need a point, and I'm going to need a slope. Then it says tangent to the graph of 2e to the x minus 8 at its x-intercept. Okay, so for the point, I'm going to put here that I want an x-intercept. Okay, and this is going to make you just have to think for a minute. If I want to be on the x-axis, that tells me something about my point. Where is the 0 going to have to be, as the x or the y? The y. Think about it like this. This is the x-axis, right? If I want to stay on the x-axis, my y has to be a 0 so that I don't go up or down and I stay right here in the middle, right? So I automatically know that it's something, comma 0. So instead of them giving me the x this time, they're giving me the y, but I still use the original function. Okay, so we're still going to use the original function here, and we're going to use the derivative over here. Okay, that's not going to change. What is going to change is where I plug the number in. Now my x isn't a 0, my y is a 0. So instead of plugging in my 0 here, I'm going to plug it in on this side. So my equation is going to be 0 equals 2e to the x minus 8. And I'm going to just have to work backwards to find that x. All right, I hate solving with 0 on the left. So I'm just going to scribble it out and make it equal 0 on the other side. If you don't want to do that, that's fine. Okay, because it's not wrong to put it on the other side. How do I get rid of a minus 8? Okay, plus 8 to both sides. What is 0 plus 8? 8. Next step, take a guess. Divide by 2. Very good. We should have done this in pre-cal last year. That means that e to the x equals 8 divided by 2 is 4. Okay, last step. When you're in pre-cal, how'd you cross out e's? Oh. Yes, ln. Very good. So I'm going to ln here, ln here. Which means that my x value is whatever the ln of 4 is. Okay, now you have a calculator. If you want to estimate what that is, you can. Okay, but if you just leave it as the ln of 4, that's fine, because it's certainly easier to put ln 4 than to put that whole decimal, right? So I'm just going to leave it like that. Okay, now let's take the derivative. What was the derivative of e to the x? It stays, it's its own derivative. Do you remember that? So two e to the x for my y prime is gonna be two e to the x again. What about the -8 when I take the derivative? Doesn't have an x with it, so that means it's a constant, it goes to 0. Okay, then this is the formula for any slope that I want. I want the slope at ln 4. So I'm gonna plug in 2e to the ln of 4. Okay, now, when we were solving this, what happened when I ln'd on an e? They did what? Canceled out. Same thing happens in reverse. If I e on an ln, what's gonna happen? Gone, and I'm just gonna be left with 2 times 4, which is what number? 8. Now, notice it's not 2 up to the 4. When these cross out, okay, your 4 is just all that's left. You would still multiply with 2. So my slope is an 8. That's enough information for me to write the equation of the tangent line. Y blank equals blank x blank. My slope goes in the middle, which was an 8. My x was in ln 4, so I'm going to put minus ln 4. And then if my y was a 0, you can put -0, but I probably wouldn't. So I'm going to rewrite that as y equals 8x minus ln. Okay. But if you put the -0, it's certainly not wrong. It's just kind of not needed. Okay. Does that make sense? Okay, so what I want to do is I'm going to cut the notes in half. We're going to do a little bit of the homework, and then we're going to come back and just do 2 more questions. Okay, so for right now, pull out your Chromebooks. If you need some scratch paper, let me know. And we'll do the first half of the homework right now. We'll come back and do the second half later. The yellow dot, make sure you do click and slide the yellow dot. Yes. Okay, and we will do the first one together, but you can kind of mess with it if you can figure it out. Y'all need paper over here? Yes. Oh, and that was really long. Can y'all try to kick it this way under y'all stuff? I bet that one sits for you. Okay. I'm not gonna do very many examples, but I'll just do the first 2. Did you already get it? Oh. Okay, for the first 2, what it's wanting is for you to move the yellow dot. Okay, which, where is my yellow dot? Oh, it's right here. Okay, we want to move it so that we're going to be tangent at 5. Now notice you already have your first dot here. So you're just wanting to kind of like adjust where your dot is so that it's smooth and connected through 5. Okay. So here's what we're going to do. We're going to take our yellow dot. And right now, is this tangent? Is it like matching the slope or is it just cutting through? Okay, that's just cutting through. So I want to match it so that the steepness of my line perfectly kisses, okay, the equation at the same steepness. So you want to adjust that yellow dot so that if you look at the zoomed in version, it should look almost just like one line because they're so like perfectly on top of each other. Does that make sense? Okay, go ahead and hit submit and go to the next one. You're wanting to perfectly match the steepness of the graph at that spot. Do I need to leave this up here longer? Yes. Okay, go to the second one. I'll reset you in 1 sec so I don't record all your grades on here on the video. Take a look at your second one. Looks like this. Okay, I want to perfectly match this slope. Now look how steep this is. Let me use my pen. Okay, it's flat, 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 flat. Then all of a sudden it goes vertical. Your tangent line should match that steepness. So if it's straight up and down, your vertical line should look straight up and down. So I'm going to take my yellow dot here. I'm just going to go like whoop. Okay, and notice that on the zoomed in version, it almost looks like it's just one line there in the middle because it's matching the slope exactly. That's what you want for those. Okay? All right, you can do the first several questions. Okay, I'll give you probably like 15 minutes, work some out, and then we'll finish the notes. Okay. So for your tricky ones, we want this equation slope to be 3. We're going to take the derivative, then set it equal to that number. Let's do it. Take the derivative of this for me. Write it on your paper. So I'm going to do 3 times a third. What's my front number going to be? 1 x to the what? Squared, because I have to power it down 1 notch. Okay, and then minus my x is an x to the 1. So my 1 comes down to the front. And then my x drops to a 0 power, which means I don't put it. This is the slope anywhere, but I want it to equal 3. So I'm not plugging in 3, I'm setting equal to 3. So step number 2, I'm going to take that equation, I'm going to set it equal. Okay, how would we solve that? How do I get rid of a minus 1? Plus 1. 3 plus 1 on the other side gives me 4. And then last step, take the square root. Okay, some of y'all on your test were confused how this gives me 2 answers. Okay, remember when you square root, what do you put in front of the solution? Plus or minus the square root of 4 is 2. And so if I were to look at my graph here, what that means is that if I count out here to 2, my slope is 3. And if I count back to -2, my slope is also 3. So I'm basically finding the places on the graph where that slope happens. Okay, now I want you to go back and read the instructions. Did we find the coordinates of points or just x values? We just found x values, right? So this is why I had you get a calculator, is it'll just make it a little faster. Okay, will you type this into your y equals? And then find the y's that go with 2 and -2. Okay, so for the points, it's going to be 2 comma something and -2 comma something. Okay, the pretty fraction, if you don't know where to find it, is alpha x. So that you can have your answer come out as a pretty fraction. Okay, so it's 1/3. Then x was to the 3rd power minus x. Now notice I'm typing in the original equation because I'm wanting y values, not the derivative. That tells me slope. If I want a y value, I need to go back to the original. Then I'm going to find the partners for 2 and -2. 2's partner I can see is 2/3. Can somebody tell me the y value for -2? Correct. Okay, so if it says I want a slope of 5, you take the derivative, set it equal to 5. You want a derivative of 12, take the derivative, set it equal to 12. Okay, do we feel like we can do that? All right, go down to last question we're going to do today is number 3. What type of slope, read through it, what type of slope do I want in that question? What does it say? Horizontal is what number? 0. So I'm going to take the derivative. And then I'm gonna set it equal to 0 because I want a horizontal slope. Okay, so let's do that. Take the derivative here. Step number 1. Nice, easy polynomial here. What's 3 times 2? 6. X cubed drops now to an x squared. Next term, 2 times 3 is 6. X squared drops to a regular x. 36x is to the 1. 1 times negative 36 is a negative 36. My x drops to a what? To a 0, it's just gone. Okay, that's the derivative at any point that I want, but I want the derivative to be horizontal. So I'm not going to plug in 0, I'm going to set equal to 0. So I want 0 equals 6x squared plus 6x minus 36. This is like step 1 and then step 2 in case you are wondering what is that. Okay, from here, how do I solve it? Okay, good. When I let first period do this, a bunch of them started like adding the 36 across. Okay, don't do that. If it's a trinomial, the only way for you to solve it is to factor. Now, if there's a GCF, I should take that out first. Is there a GCF? They can all divide by what? 6. So I'm gonna have 6 to the front. That's gonna give me x squared. My 6x divided by 6 is now a 1x. And my 36 divided by 6 is just a 6. A, B, C. Remember, the top of your chart is your AC number. Bottom of the chart is your basement number. Remember, for AC, you're multiplying the A and the C. So if this is a 1 times a negative 6, that's a negative 6. And how can I times to get the number 6? 1 and 6, or 2 and 3, or 3 and 2, same thing. Very good. From there, I want my numbers to minus to give me a B of 1. So which of those will minus to 1? 2 and 3. And if I want my 1 to come out positive, where should I put the 1? On the little number or the bigger number? On the littler number, on the 2. Very good. So I have x minus 2 and x plus 3. If my A is a 1, I'm done. Is my A a 1 this time? Yes. Remember the 6 that was there, we pulled that out. Okay, that's gone. My A is a 1, so I'm done. My factors then are x equals 2 and negative 3. Now, in case you're curious, remember we did have this 6 in the front. Okay, remember that if that 6 isn't accompanied with like an X, it doesn't give you any extra answers. So you can basically pretend the 6 isn't there. You only care about the answers for X. Okay, now, if it said to find the points, would this be enough? No, but what does it say? Finds the what? The X values. Did I find X values? Then I don't need to go back and find like the Y's that go with it. That would be sufficient. Okay? All right, you can do your whole homework now. You have a little bit more time. Ask me if you need help. Yeah. Yeah. Oh, great. Did you already look up your grades? Was your transfer grade bad? Basically every one of mine that you do, I'll just switch it out. Yes.
So you want to do 3? How does that work?
So what I would do is just pick one of my homeworks. It'll show up in your past due section and then just do it. And when you're finished with it, it'll still give you a 0 on Delta Math. Email me and then I'll give you credit for it. But if you do it after the due date, it just won't tell me you did it. But if you email me and tell me, then I'll take the late penalty off and still give you full credit. And then I'll replace